Hello, now we shall discuss numerical methods of second sem, module 5. Topic is finite differences, interpolation and extrapolation. The application of numerical methods in calculus are it is to find or estimate y values in terms of or in an interval where an in-between value of x is given. And also we can also find numerically the derivatives and integration of functions, and also we can find the solution of some algebraic and transcendental equations. So now in this session let us understand what are the finite differences. Suppose there is a function y is equal to fx defined in an interval with the values of x given in the below data or table. X values are from x0 to x4 and y values are y0 to y4. Each xi are equidistant points. Then we can observe that the difference of two xi values will be always same, that is denoted by h, and h is common difference, or it is also called as step length. And also we can define x1 x2 in terms of x0 and h as x1 is equal to x0 plus h, x2 is equal to x1 plus h, x3 is equal to x2 plus h, and so on. The last value x4 is equal to x0 plus 4h, where h is called the step length. So further we can find the values of y corresponding to any value of x between x0 and x4. It is called interpolation. And computing the value of y outside the given interval or the range is called extrapolation. And now let us understand what are finite differences or finite forward differences. We will subtract y1 minus y0, and that subtraction is denoted by del y0. Similarly, y2 minus y1 del y1, y3 minus y2 del y2, y4 minus y3 del y3. These are first forward differences. And again we will subtract these differences in the following manner: del y1 minus del y0, that difference is denoted by del square y0, del y2 minus del y1, that is denoted by del square y1, and so on, del y3 minus del y2 del square y2. These are second order forward differences. Similarly, we can find third order forward difference as del q y0 and del q y1. Here the symbol used called del is called as forward difference operator. Now let us see how to construct a difference table. Let us write the x and y values in first two columns, x0 to x4 and y0 to y4. In first difference column, del y0 is obtained by the difference of y1 minus y0, del y1 is obtained from y2 minus difference of y2 minus y1, and del y2 is obtained from the difference of y3 minus y2, and also del y3 is obtained by the difference of y4 and y3. Similarly, in second difference column, del square y0 is obtained by the difference of del y1 and del y0. Del square y1 is obtained from the difference of del y2 and del y1, and del square y2 is obtained from the difference of del y3 minus del y2. Similarly, del q y0, del q y1 are obtained, and in the last column del to the power 4 y0, and these upper values called del y0, del square y0, del q y0, del to the power 4 y0 are called as leading forward differences. And then backward differences, finite backward differences. Let us obtain the differences as follows. y1 minus y0 difference is represented by a symbol called inverted del y1. Also, y2 minus y1 is denoted as del y2. y3 minus y2 is equal to del y3. y4 minus y3 is equal to del y4. These are the first backward differences. Similarly, the second backward differences are obtained from the differences of del y2 minus del y1 is represented by or denoted by del square y2. Del y3 minus del y2 is equal to del square y3. Del y4 minus del y3 is equal to del square y4. These are second order backward differences. And the backward difference table is written like this. Again, x and y values in first two columns. In first difference, del y1, del y2, del y3, del y4. And the second difference or second difference column, del square y2, del square y3, del square y4. And in the last column, it is del to the power 4 y4. So let us take an example and find or obtain some of the differences. It is given that x values are 0 to 4 and y values are 4 to 156. Let us construct the difference table and obtain the values of inverted del f76, del square f13, del to the power 4, 4 it is. The difference table is again first two columns x and y values, these are the given values, and in first difference 12 minus 4 gives del y naught, 13 minus 12 is 1, 76 minus 13 is 63, 156 minus 76 is 80. So these are first differences or first order differences. Similarly, second order differences are obtained from 1 minus 8 is minus 7, 63 minus 1 is 62, 80 minus 63 is 17. And say in the same manner the third difference column values and fourth difference column values. And we can also define backward differences like this. It is y1 minus y0 is equal to del y1 is 8, y2 minus y1 is 1, and y3 minus y2 is 63, and similarly y4 minus y3 is del y4, it is 80. And now let us evaluate backward difference called inverted del of f76. It is del y3 is 63. Del y2 minus del y1 is equal to del square y2. From the table, del square y2 is minus 7. And del y3 minus del y2 is equal to del square y3. From the table, it is 62. Del y4 minus del y3 is equal to del square y4. It is 17. And further it is del square f13 is nothing but 13 comes at y2 position. So del square y2 is minus 7. And also del square y3 minus del square y2 is nothing but del cube y3. Del cube y3 from the table is 69. Then del square y4 minus del square y3 is equal to del cube y4. From the table it is minus 45. Therefore, del cube y4 minus del cube y3 difference is del to the power 4 y4. It is minus 114. So we got the value of del to the power 4 f4, nothing but del to the power 4 y4 is minus 114. In the second example, we can find the missing term from the table. Say x values are given, y values also given, but one term of y is not given. That can be evaluated as follows. Let us assume a missing term be a. Only four values of y are given. Therefore, let us assume that the last difference called del to the power 4 y is equal to 0. You write first column and second column as x values, y values, and obtain the corresponding differences of the given data. And these are the first difference, second difference, third difference, fourth difference. And then since we have assumed that the last difference called del to the power 4y is equal to 0, then 240.2 minus 4a is equal to 0. Therefore, a value is 60.05. So this is how by a difference table we can find the missing term of the given data. And we can observe that in a difference table all upper values are leading forward differences and all lower values are leading backward differences. And also we can write x1 as x0 plus h and x2 plus 2h and so on, an rth term called xr is equal to x0 plus rh. And here XOR is the rth term, H is the step length. Therefore, in general, X can be written as X is equal to XOR equals X0 plus RH. That is, R can be obtained. The rth term or rth position can be obtained by R is equal to X minus X0 by H, where H is the step length between the points of X values. And further, let us understand what are Newton's interpolation formula or Newton's Gregory forward interpolation formula. This is one such formula we can use to estimate the function when x is given at the initial point of the interval. That is, this formula is useful to find the value of fx at some point x, which when lies near the starting point of the interval. So this is your given interval called x0 and xn. Whenever you want to find y value or fx value of at x when x is near the initial point called x0, then in that case we will have to find one value called r. As we had defined earlier, x is in general written as x0 plus rh. Then r is given by x minus x0 by h, where h is the step length from the given table or given data. And now the forward interpolation formula or Newton's forward interpolation formula is defined as y is equal to fx, that is equal to y naught plus r del y naught plus r into r minus 1 by 2 factorial del square y naught plus r into r minus 1 into r minus 2 by 3 factorial into del q y naught and so on. So where del y naught, del square y naught, del q y naught are the upper values of the difference table, or they are also called as forward leading differences. Similarly, another formula, Newton's Gregory backward interpolation formula. This formula is useful to find the value of y or fx at some point x. This x lies at the end point of the interval called x0, xn. Whenever that x lies near the end point called xn, then we use this formula known as Newton's Gregory backward interpolation formula. And here we need to find r value using this formula called general x is equal to xn plus rh, whereas in forward interpolation formula x was x0 plus rh. Now this x is now xn plus rh. So therefore r is defined as x minus xn by h, where h is the step length which can be obtained from the difference of two consecutive values of x. Then backward interpolation formula is defined as y equals fx, that equals yn plus r del yn or inverted del yn plus r into r plus 1 by 2 factorial del square yn plus r into r plus 1 into r plus 2 by 3 factorial del cube yn and so on. We can observe the difference between forward interpolation formula and backward interpolation formula. It starts from y naught, and also here these are the forward difference operators or forward differences, whereas in backward interpolation formula starts from yn and del yn, del square yn, del cube yn. These are the lower values in the difference table called as leading backward differences. And further, Let us choose an example and work out this forward interpolation formula. Here, a function y is equal to fx is given by the following table. Here, x points are 1 to 2 and y values are 0 to 4. Question is, find an approximate value of y at x is equal to 1.1. So, whenever you are solving the problem, first observe y has to be estimated or y has to be determined at what value of x. So, here x is equal to 1.1. 1.1 lies near the starting point or initial point of the x values. Therefore, we must apply forward interpolation formula. And as usual, let us formulate or obtain the difference table. First, given two columns are x values and y values. First difference is obtained by y1 minus y0. The difference is 0.128. Similarly, y2 minus y1 0.416 and so on. All other values can be evaluated. Similarly, the second difference column, third difference column, and in last column it is 0, 0. Fourth difference is 0. Then we shall write the forward interpolation formula as y is equal to fx, that is equal to y naught plus r del y naught plus r into r minus 1 by 2 factorial del square y naught plus r into r minus 1 r minus 2 by 3 factorial del q y naught. Formula stops only here because the fourth difference is 0. And now we need to find r value. R value is evaluated here. To find y is equal to y is at x is equal to 1.1, which lies near initial point of the interval 1 and 2. And let us choose interval as 1 2 is equal to x naught comma x5. Then r is given by x minus x naught by h. Whenever x lies 1.1 is near the initial point of the interval, r formula is written as r equals x minus x naught by h. Then if you calculate, r value will be 0.5. And then we apply the Newton's forward interpolation formula, substitute all values, simplify, you will get y is equal to fx, that is equal to 0.031. This is the y value whenever x value is 1.1. And in second example, the areas A of circles for different diameters d are shown in the following table. So these are the different diameters and these are the areas. Choose this row values as x values and a values as y values. And question is, find area when d is equal to 82. 82 lies near the starting point or initial point of d values or x values. Then formulate the difference table. It is as usual method. These are all the forward leading differences and these are all the backward leading differences. Then h value is x1 minus x0. 85 minus 80 is equal to 5. Since we have to find the area A when d is equal to 82, which lies near the starting point of the interval, then r is given by x minus x0 by h and whose value is 0.4. Then we use forward interpolation formula and correspondingly del y naught, del square y naught, del cube y naught, del to the power 4 y naught are from the table. So these are the upper values. And use the formula, substitute all values, simplify, you will get y value 5280 at the point x is equal to, it is given as in the previous page it is 82, x is equal to 82, it is y value or area will be 5280 square meter or in some units. In example 3, from the following table, estimate the number of students who obtained marks between 40 and 45. This problem is very important, and here a difference of two values have been given. This is to be rewritten or rearranged in the cumulative form as it is up to 40, up to 50 and 60, 70 and 80, and corresponding Okay, we are rewriting the given data called marks and number of students. Here marks are between 30 to 40, number of students are 31, marks between 40 and 50, number of students are 42, so on. It is last value of X series is 80 and 80 marks, number of students are 31. This is rearranged as follows. In the marks row, fix up the end value of this column, that is 40, 50, 60, 70, 80. Number of students scored 40 marks or up to 40 marks is 31, and the number of students scored up to 50 marks is 73. 73 comes by the addition of 42 plus 31 is 73. Similarly, number of students who scores up to 60 marks is 124. 124 comes from the value called 51 and its previous value 73 is 124. Similarly, up to 70 marks 159 students, up to 80 marks 180 students. So this is called cumulative frequency table. And then write x values, y values, and then first order difference, second order difference, third order difference, fourth order difference. So we need to find y value at x is equal to 45. This number 45 lies near 40, that is starting point of the interval. So when it is lies near the starting point of the interval, r will be evaluated from this formula x minus x naught by h, that is r value is 0.5. We use forward interpolation formula, that is y is equal to y naught plus r into del y naught plus r into r minus 1 by 2 factorial del square y naught and so on up to it is del to the power 4 y naught. Substituting all values and simplifying, we will get 47.87. It is approximately equal to r rounded off to 48. And therefore the number of students with marks less than 45 is 48, and by data the number of students with marks less than 40 is 31. Hence the number of students getting marks between 40 and 45 is 48 minus 31 is equal to 17. In next example, find the interpolating polynomial for the data. So data is x values are 0, 1, 2, 3. Y values are 1, 2, 1, 10. Hence, evaluate y of 0.75. So here we have to find the y value at x is equal to 0.75. So what do we need to find first? Find the interpolating polynomial, that is an expression in x. First let us formulate the difference table. Write x values, y values, first order difference, second order difference, third order differences. Okay, and first let us find the interpolating polynomial in x using forward interpolation formula. Therefore r can be computed using r equals x minus x naught by h, that is x minus 0 by 1. H value is 1, x naught value is 0, therefore r is equal to x. And by forward interpolation formula, this is the formula, and write r is equal to x del y naught value, del square y naught value, del cube y naught value. Substitute and simplify, you will get yx is equal to 2x cube minus 7x square plus 6x plus 1, and this is the required polynomial. And further we need to find y value at x is equal to 0.75. Substitute x is equal to 0.75, you will get 2.406. Next example, a survey conducted in a slum locality reveals the following information as classified below. Income per day in rupees less than 10 rupees, between 10 and 20, between 20 and 30, between 30 and 40, between 40 and 50 rupees. And number of persons who are earning less than 10 rupees is 20 persons. Number of persons earning rupees between 10 and 20 is 45. number of persons earning rupees 20 and 30, 115 and so on. Number of persons earning rupees 40 to 50 per day is 115. Now question is, estimate the probable number of persons in the income group rupees 20 to 25. We have to find number of persons who are earning rupees 20 to 25. Let us rearrange the data as number of persons earning rupees 10, 20, 30, 40, 50 rupees. So this row represents the number of rupees they are earning, and second row, that is number of persons who are earning less than 10 rupees is 20%, less than 20 rupees is 65%. 65 comes from the cumulative addition, 45 plus 20 is 65. Similarly, rupees 30 or less than 30 earning people or number of persons are 180, and also 390 is the number of persons who are earning less than 40 rupees, and 505 people are earning rupees 50. And the difference table is X column, Y column, first order differences, second order differences, third order differences and fourth order difference. H value is obtained from the difference of x1 and x0, that is 10, and del y0, del square y0, del cube y0, del to the power 4 y0 are the leading forward differences from the difference table. These are those values. And R value is R equals x minus x0 by h, and it is 0.5. So now using forward interpolation formula, and in this formula choose y0 as 65. Why? Because it is we are estimating actually y value at the point x is equal to 25. So therefore in next column 20 will be considered as initial point, and hence the y value 65 will be taken as the initial point of y. Then when y0 is 65, then r values, del y0 values and up to del to the power 4 y0 values will be substituted, and simplifying, so it amounts to 88.71 and approximated as 89. Hence the number of persons with income rupees 25 is 89. Therefore the probable number of persons in the income group between 20 and 25 is 89 minus 65 is 24. So these are the examples for uh, using Newton's forward interpolation formula. In my next video, I will explain how to use or what to use or when to use Newton's backward interpolation formula with some examples.